So now lesson 15C, the power of the pill, begins with a study. It was conducted with 66 chronic migraine headache sufferers. Patients were given a pill to treat their pain. Pain levels were measured before and after taking the pill. On average, pain was reduced 26% after 2.5 hours. Did this study prove that the treatment is effective in reducing pain? Think about whether there are confounding variables that offer an alternate explanation for the patient's improvement. This is a great time to hit pause, jot down a couple of thoughts, even read the objectives, and keep going to question 2, and then come back and we can walk through some of this together. Talking about question 1, if people believed that the pill would work, that may have been enough to help them make them feel better. However, this improvement does not mean that the treatment worked. Thus, the study did not prove that the medication works, but we're going to discuss and look at some ways that we can show that the treatment works. Looking at the objectives for this lesson, you're going to begin to understand that. And some interesting stuff here. The belief that a treatment will help may bring about improvement for some ailments, and this improvement is known placebo effect. Make sure you write that down. The belief that a treatment may bring about improvement is a confounding variable unless members of a control group receive a placebo. Blinding is when patients do not know if they're receiving a treatment or a placebo. Double blinding is when neither the patients nor the research contact knows who is receiving a treatment and who is receiving a placebo. So we're going to be looking more at and begin to be able to decide when an experiment should introduce a placebo to control confounding. And we're going to design a double-blind study that uses a placebo to control confounding. The treatment that was given to the 66 patients above in the migraine study was a placebo. It was a pill filled with inactive ingredients. Nonetheless, the pain levels were decreased by 26%. This positive response to a fake treatment is known as the placebo effect, and I would jot down that this positive response to a fake treatment is known as the placebo effect. Looking at a different study, patients were divided randomly, so start noticing, picking up on, honing in on words randomly. 2 groups. One group is receiving a well-known migraine headache medication called Maxalt, while another group received nothing. On average, there was a 40% decrease in pain levels, and then after 2 hours for the group receiving Maxalt, on average, there was a 40% decrease in pain levels after 2 hours for the group receiving Maxalt. The group who received nothing had a 15% decrease in pain. Part A, the patients were divided randomly. So this is excellent. So the groups should be roughly similar. Unfortunately, there is still a confounding variable in this study. Do you see it? Jot down a thought. So one group received a pill that they believed really might cure them. This was not true for the other group. The other group got nothing. The belief varied between the 2 groups and was therefore a confounding variable. Can we say, without a shadow of doubt, that Maxalt causes a decrease in pain levels for migraine sufferers based on the results of this study? And talk about your answer. And the answer is nope. We cannot make this conclusion because of the confounding variables. So, when there is a confounding variable in study, there is an alternate explanation for the changes that are observed. And what is the alternate explanation for the changes observed in this study? Well, simply that taking a pill led the volunteers to believe that they were feeling better. It's a placebo effect. One group had a pill, the other group had nothing. And so we cannot conclusively say the difference was based on max salt. Part D, what then is a possible remedy for the confounding caused by providing the max salt pill? So, what possibly could we do? Well, we could or should give max salt to one group and a placebo pill to the other group. Now everybody's getting a pill, just nobody knows what's inside of their particular pill. Continuing on with this study, if we give a placebo to one group and max salt to the other, which group is the treatment and which group is the control group? The treatment group will be the group that gets what we're trying to find out if it's making an impact. It's the actual treatment that we want to make an inference about. The control group is going to be the group that gets the fake pill, the placebo. Because even after getting both groups getting a pill, if we then notice that the max salt group has a greater difference, and I'll just wait and let us talk about it in the results, but the pain goes away, and it goes away, well, keep talking. Part F, if we give a placebo to one group and max salt to the other, and the patients know what they're getting, If we give a placebo to one group, max salt to the other, and the patients know what they're getting, do we still have a confounding problem? Like I look at you and say, hey, here's a placebo. Hey, here's a max salt. Explain your answer. And the answer is yes. That definitely is a confounding problem if people know what they're getting, especially if they know they're getting the placebo, because they must believe in the pill the same way that the people who get the max salt do. They must have this belief held constant between the two groups, that both think that they're getting the max salt, but yet one has something fake on the inside. When we say that an experimental study implements blinding, that's what we mean. We mean that the patients do not know if they are receiving the real thing or the placebo. And usually the volunteers sign a statement that they understand that they may receive an active treatment. They also understand that they may receive a placebo. So this is where it's getting good. Some studies have shown that the person who gives the placebo to the patient can influence its effect. An eye wink or sarcasm like, hope this helps you, for instance. If the doctor or nurse says that it is a powerful medication that will help them, the placebo effect can be stronger. So the question is, should the person who gives the placebo to a patient know that it is a placebo? And the answer is no. If they do, they may act differently, which can impact, change the placebo effect. The person receiving the medication needs to believe that it's really something that's going to help them so that we can really study if the true difference is happening from the treatment or by some other confounding variable, or that there's not even a difference. In a double-blind study, neither the patients nor those who interact with them know who is receiving the placebo. If an experiment is double-blind with similar groups, okay, get big words again. It's double-blind. It has similar groups. Similar groups were created, random assignment. One group is receiving a treatment, and the other group is receiving a placebo. And when we get our results, the treatment group improves significantly more than the control group. Can we conclude that the treatment is really effective? Yes. Now that the confounding imposed by the placebo is controlled, we can conclude that the observed difference, we now get to say that the observed difference, this improvement, is caused by the treatment. Depending on the ailment, the placebo effect can be almost as or more powerful as the drug itself. In the study described at the beginning of the lesson, patients were given pills with different information. When patients were given a placebo but told it was max salt, the pain reduction was statistically similar to when patients were given max salt but told it was a placebo. The most powerful combination was when patients were given max salt and told it was max salt. Number 4, suppose that in an experiment, 3 groups were given 3 different dosage levels of a new experimental medication, 10, 20, and 40 milligrams each. If each group experienced some improvement in the way that it was intended, why had this improvement occurred? You have 3 thoughts, A, B, and C. The medication was effective. The experiment was not effective. Without a control group, we cannot be sure that the improvement was due specifically to the medication. Well, here's our winner. We may see some improvements, but there are many parts to an effective experimental study, and one of those many parts would be that we have a control group. This concludes our lesson, but there are a few things that I would like to read to you that are in my notes and for you to add to your notes. I cannot stress enough that you write down, memorize, think through that confounding variables keep us from making accurate conclusions about cause and effect. And I keep mentioning healthy paranoia. Always be thinking, what if? Could it be something else? What else is going on? Is it a good study? Is it random? Is it similar? Keep all of those thoughts rolling through your brain. Then a couple of other thoughts, either to listen to or to write down. The overall goal is that you and I are working through the idea of placebo effect in our experimental studies and how to control it. And it's always good when you get through studying something to write down your own personal summary of what it is not. The other thoughts that we talked about, placebo effect. If one group of patients receives a treatment but the other does not, the treatment group's belief in the treatment may bring about an improvement that is not even related to the treatment itself. In this study we were looking at, when one group believes that the treatment will help them, but the other has no such belief, like the very first study we looked at, then the experiment is confounded by this variation. I'm getting something and you're not. We cannot say it's based on the treatment. It is best if both groups get a treatment. And it is best if not only one part of the study is blind, but that we actually have a double-blind study where neither the patients nor the practitioners know who is receiving the placebo. One last thought. In a double-blind study, when a treatment group improves significantly more than the control group, then researchers can conclude that the treatment is the cause. So this finishes lesson 15C. Go look at your syllabus to see if you have more to do this week. If you do, keep going. If you don't, do that happy dance, that celebration, and I'll see you again next week.